Dear students, in this chapter you are going to learn about finding the limits for the double integration over the given region R. So the following example will give you a clear idea about how to find the limits for the given double integration. So as we discussed in our previous video, the double integration for the function f of x comma y can be of an order dx dy or dy dx. Now, if your given integration is of an order dx dy, you are going to take the horizontal strip. That means you are going to shade the region by horizontal lines. If it is of an order dy dx, then you are going to take the vertical strip. It means you are going to shade it by vertical lines, right? I repeat again, if it is of an order dx dy, you are going to shade the region of the given integration by horizontal lines. If it is dy dx, you are going to shade it by vertical lines. Now keep this simple logic in your mind. Let us see first the limits for the given integral f of x comma y dx dy. So if it is dx dy, as I said before, you are going to shade the region by horizontal lines. Before you shade the region, let us see the endpoints of the given graph. So this point is 0 comma 0, and this point is 4 comma 4, and this point is 0 comma 4. Now the y-axis, the equation is x equal to 0. The x-axis, the equation is y equals 0. So once after you find all these points, now we are going to shade the region of given integration by horizontal lines. Look at, this is your integrating region. Okay, we are going to shade this region, the triangle, by horizontal lines. When you draw the horizontal lines, you have to start from the left side and you have to stop at the right side. And similarly, you have to start at the bottom and then you have to go to the top. Let us see. So I will start at the black color line to the red color. I will finish it at the red color line. So I will start at the black color line. I will finish it at a red color. Black to red line, black to red line, black to red line. Until the end of this region, the color varies from the black color to the red line, to the red color line. So we start at the black color. So what is the value of x at black color? The equation of your black line is x equals 0. When I stop, that means the red color. When I stop, what is the value of your x? X is equal to y. Y equal to x can be written as x equal to y. So this is your upper limit. The starting point is the black color, so x equals 0. The end point is your red color, that is x equal to y. Now look at the line. The line is moving from the lower end to the lower to upper. So that means when you start, what is the value of your y? It is 0. And when you stop, when you start, what is the value of your y? 0. When you stop, what is the value of your y? Y equals 4. So this is the limit for the given integral of the order dx dy, right? Now let us see the same region and how the limits will be for the order dy dx. So let me change the order of the integration to dy dy dx. So if it is of an order dy dx, so what does it mean? You are going to shade the given region by vertical lines, right? Let us see. If it is dy dx, I am going to shade it by vertical lines. When you are shading from the vertical lines, look at this region. I am going to start at the red line. I will stop at the blue line. So red line to the blue line, red line to the blue line, red line to the blue line, until the end the color goes from the red color line to the blue color line. So now what is the value of y and red color? Y equals x. And what is the value of y in the blue color? When I stop at blue, what is the value of your y? It is 4. Now look at the line. The line varies from the left side to the right side. So when I start at the left side, what is the value of your x? X is 0. When I stop here, what is the value of your x? It is 4. So if your given order is dy dx, then the limit of the integration is integral x to 4, 0 to 4. The inner limit is x to 4 and the outer integral limit is 0 to 4. Right? When you integrate, for this both integration the limits are different, and when you integrate the function you will get the same value. So don't bother about the order, the final value will be same for both the integration. I hope this problem is clear to everyone. Now let us move on to the second example. Look at this integration. Now let us find the limits of this region for the order integral. It can be any function dx dy. So if it is dx dy, as I told you, we are going to shade the region by horizontal lines, right? Before we go for the shading, let us find the end points. So this point of intersection is 1 comma 1, and this point is 0 comma 0, and the equations of the line and the curve is given to you. Now let us shade the region by horizontal lines. So when I shade, I have to start from the left side. So when I start from the left side, it is a red color. A red line to the blue curve, 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 a red line to the blue curve. So until the end of the region, uh, the variation is from the red line to the blue curve. What is the value of x? What is the value of x in the red line? X equals y. So x equals y, and here we have x power 2 equal to y. So that means x will be square root of y. Everyone knows that when you take the square root, it will be ending with a positive value and the negative value. And look at here, this region x is positive, and this region x will be negative. So we take the positive square root of for the value of x as positive square root of y. So the limit varies from x equal to y to x equal to square root of y. Now look at the line. The line is moving from the lower to the upper. When I start, what is the value of your y? It is 0. When I stop, what is the value of your y? It is 1. So outer limit will be 0 to 1, and inner limit is y to square root of y. I hope this explanation is clear to everyone. Now let us see the same region, and what is order for dy dx. So the order is dy dx. If it is dy dx, you are going to shade the region by vertical lines, right? So when you are drawing the vertical lines, the line will start from the blue curve to the red line, blue to the red, blue to the red, blue to the red, blue to the red. So the starting point of your line is the blue curve and the end point is your red line. So what is your value of y in blue? So the value of y is x power 2. What is the value of y in red? Y equals x. So now look at the line. The line is moving from the left side to the right side. So when I start at the left side, what is the value of your x? 0. When I stop at this point, what is the value of your x? It is 1. So the limit of your integral is, inner integral is x power 2 to x, and the outer integral limit is 0 to 1. This is the limit for the order dy dx. I hope this limits explanation is clear to everyone.